Hi, welcome to my latest video. Today I'm going to be filming part 3 of my rear diff and Haldex video series. In part 1 I separated this Gen 3 Haldex from an old rear diff, and then in part 2 I showed this, which is the new reconditioned rear diff that I part exchanged with the old one that was attached to the Gen 3. So I took that to Bell Engineering and they gave me this one, which has uprated bearings in there. Now they didn't paint it orange, that was me, okay? And those of you who watched my last video, my vlog 6 video, will have noticed that this maybe isn't quite as bright orange as it was. Okay, it's nice and orange, but it was even brighter. Okay, why have I painted it orange? Why not? Okay, there is no reason at all. It's not going to be visible. The MOT tester is the only person that's going to see it, but I just had a crazy idea of let's paint it orange for the fun of it, purely for the fun of it. Okay, so I tried to mix up some orange paint and I put that on in the last video, and it didn't look very good. It really wasn't very bright at all. So then I got my hands on some very, very bright neon orange paint, which is this sort of colour. Okay, and I sort of jokingly said that it was used to paint signs in the tunnels. A bit of a reference to Only Fools and Horses there, with the luminous paint that they painted the Chinese takeaway kitchen with. Okay, but it was as bright as that. Okay, it was so bright that my camcorder was actually underexposing. Okay, so it looked good, but the problem with this bright orange paint is it's very thin, very translucent. You can see there, this is I've put about 5 or 6 coats on this shackle here, and you can still see through it. Okay, I just wasn't happy with the finish. It looked great in the video, but up close it didn't look good at all. Okay, the orange was lovely and bright, but the paint was very matte, very thin. It just wasn't like this. It wasn't hard wearing glossy enamel coating like hammerite paint, okay, which is what I wanted. So I found this. Okay, so this is E-Tech brake caliper paint, and I bought that for my brake calipers. Well, not the ones actually on the car. These I've got new front and rear calipers that I've bought, and I'm going to be doing a uprated brake overhaul video series soon, okay, with braided hoses and big vented discs and all that, and I'll talk about how you can actually sort of fit bigger brakes to the standard Freelander 2. Okay, so all of that's coming up. So I bought these calipers, I painted it with this E-Tech brake caliper paint, and I thought this little tin is not going to be enough to do 4 brake calipers and the carriers and a whole rear diff, but it actually a little goes a long way. Okay, so it was fine. So I've given this one coat. It looks great. I think that's bright enough. Okay, it doesn't need to be glow in the dark neon fluorescent orange colour really. This is the sort of colour and finish that I originally wanted. I just had to go through about 12 different paints before I found the one that I wanted. So this has a very thick coating of paint. Now I've probably added about 1 kilogram to the weight of my car just in paint, okay, but it took a few attempts to get the colour right. So this is what you need if you want orange brake calipers and diff. It's E-Tech orange enamel. Now interestingly, this is sold as brake caliper paint. They also sell engine lacquer paint, which is exactly the same. I bought both, and the tins were exactly the same and the paint was exactly the same. The difference really is that the brake caliper paint comes in a little sort of box with some cleaner spray and a brush and whatever else, okay, but the engine lacquer comes on its own. It's the same, and possibly slightly cheaper for the engine enamel. Okay, so this is the new diff. What I've done is I've removed a few things from this. Okay, so when I got this from Bell Engineering, it was sort of just plain aluminium. Not a lot was done on the outside to recondition. It was really just inside. New bearings in here, new seals. Okay, so we've got new seals here. But the bolts, okay, and the fill plugs were the original ones. Okay, so we've got these sort of grotty fill plugs, which are just clearly used ones now. They've got orange paint on where where they were in there when I painted it. Okay, because just to avoid getting paint in the hole. Okay, so those I took out mainly because they're not magnetic. Okay, so I've replaced them with these. Okay, so these are M18 by 1.5, I think it is. I will put the size at the bottom of the screen now. Okay, and these have got that nice magnet, very strong magnet actually, I hasten to add, on the end to catch any kind of swarf and things like that. Now, these are fill plugs, okay, they're not drain plugs, but the oil will be sort of splashed around inside there, so it will still go over the magnet. This here is a drain plug. Okay, so when I bought the Diff, okay, it came with that surface was just blank. Okay, it was just a sort of odd step of metal sticking out there, and different years of Diff have different sort of locations. Some of them have a bit here, might even be a bit here. I think my one here has that bit, and that was just blank metal. So I asked Austin at Bell Engineering if I could drill and tap that, and he said yes, you can. No more than 10mm thread though. Okay, so what did I do? I went for 12mm. Okay, so I ignored his advice and I thought 10, that's far too small, I want 12. So I put in this, which is an M12, and that worked quite well, although the top threads in the hole were a little bit of a loose fit. It was just really just where I was sort of drilling it. I haven't got a pillar drill, you see, so I'm kind of doing it by hand, and the drill sort of jammed a couple of times and ended up with a little bit of an oval hole at the top. Okay, so I thought, right, all right, what I'll do is I will fit another M12 with a longer thread. Okay, so this is M12 by, I think it's a 1.25 thread there. I'll put that at the bottom of the screen. But even with that longer thread, I still wasn't too happy, and I thought, I know what I'll do is I'll ignore Austin even more, and I'm going to go to M14. Okay, because I believe there's enough metal there for that. So I made a massive mistake. I tried to tap out an M12 by 1.25 threaded hole with an M14 by 1.25, so same pitch, just slightly wider thread, thinking it'll kind of cut in and just make the thread bigger diameter. It didn't work. It didn't work at all. Something went terribly wrong, and as I was tapping it, it just sort of ripped the existing M12 thread out of the hole, and I ended up with a 14mm hole with no thread in it. And I thought, this is a disaster. I almost ruined the new Diff. 400 and something pounds, and it was almost scrap. Okay, so what I did was I very carefully then drilled out to, I think it was a 14.5mm drill or something like that, and I then threaded with an M16. Okay, so we've got an M16 by 1.25, I think that is. Okay, and as you can see, it just fits. It's a bit tight. Okay, it is a bit tight, and there's a reason why this drain plug here is red and not blue, because the blue M16 one that I bought, which I don't think it's that one, I don't know where the blue M16 went, but it had a big sort of overhang. It was hanging out much wider than this, and it just didn't seal properly. So what I then had to do was find another M16 drain plug with a magnet, with a very thin sort of shoulder on it there, okay, and I found this one in the end. I also did find a sort of one for a this one's obviously sort of Chinese kind of one, but a Renault Clio drain plug. I actually ended up on a Renault Clio drain plug, which was very similar to this. The only problem is it didn't have the magnet. Okay, so that fitted, that had the thin surround, but then I found this one with the magnet. Okay, and the good news is that fits. Okay, it threads in, it's not sloppy, it's a nice positive sort of, it's firmly in the thread there, and the thread's quite long, and it all goes in nicely. Now, that wasn't quite the end of it, because when I screwed it in there, I realised that this metal face here was slightly sloping, and it wasn't sealing, it wasn't going to seal. Basically, when this is upside down full of oil, oil's going to leak out. So I then had to get a flat file and carefully file that sort of surface so that it was dead perpendicular, so that the thread and the copper washer sealed correctly onto it. Okay, so you can see that there, that is now flat, okay, and sealing. Alright, well, I hope it seals. I'll find out when it's on the car full of oil, but I believe that that's as good as I can get it. As well as the drain plugs, I changed these bolts, okay, 1, 2, 3, 4, 5, 6, 7. There are 7 bolts which the standard Diff had, which were clearly used, and these are 35mm long. 2 of them also were these sort of like studs rather than bolts, same length, okay, also 35mm under the head, but with a bit sticking out here, apparently for some sort of mass damper thing, like a weight, counterweight or something, which I don't have and I don't want. So I took out those bolts and I replaced them with these. These are not stainless steel, they are high tensile 12.9 grade zinc plated M8 normal thread, coarse thread M8 bolts. Okay, I could have probably got away with sort of marine grade stainless, because these bolts that came out are I think 8.8 grade and tensile grade, and I think it's called, is it A4 or W4? I think it's A4 stainless is a similar tensile strength to 8.8 mild steel. So I could have swapped those, I could have had stainless, but I'd already ordered these by then. So these will eventually rust because they are non-stainless, but they're zinc plated, so hopefully they'll stay shiny for a bit. And what I did is I put a plain washer and a spring washer underneath each one to spread it to a similar size of the head of this, and because there are 2 washers under there, I went for 40mm instead of 35, and that threads in fine. The hole is actually about 40mm deep. Okay, so that's those. There are also 4 bolts that go here to bolt the Haldex to the rear diff. Okay, and those bolts are here, so the standard ones here. These are the ones that came off the old Gen 3 Haldex here, and they're M8, not M6, as somebody incorrectly stated on the Freel 2 forum. They are M8. There are 3 that are about, how long are those? They're about 45mm long, and then this one long one, which is 65mm long. Okay, so what I'm doing is replacing them with the same high tensile, what size is this? This is a 50mm and a 70mm. Okay, so 5mm longer than the standard ones. Again, because I'm going to be putting some washers under the heads of the bolts. Okay, so those are the bolts that will go in here when the Haldex is rebuilt. Right, let's talk about Haldexes now. This video is actually meant to be about the Haldexes. So these are Gen 4, this is Gen 3. These are the older ones, fitted up to around about 2006 to 2008. Had these, and then in 2009 they went to the Haldex Gen 4. Mine is a 09, okay, and mine has a Gen 4. Okay, so, and it's an 09, not a 59. So early spring 2009, they went to these, possibly even late 2008. Okay, so if you've got a 2006, 2007, 2008, you've probably got one of these. 2009 onwards, you've got one of these. What is the difference? Okay, well, these are an active coupling. They link the prop shaft into the rear diff. So you've got the engine, the gearbox, you've got the power transfer unit, and the drive shafts coming out to the front wheels. Power transfer unit sends drive 90 degrees down the prop shaft, through the Haldex, into the rear diff and out of the rear drive shafts to the rear wheels. This usually runs disconnected, so the input and the output are not mechanically connected. Okay, so the car is actually two-wheel drive. So that's a sort of normal driving when you're driving along at about sort of, you know, over 50, well, probably about 30 miles an hour. Maybe it's lower than that actually, but normal driving on a straight road, basically, the Haldex will disconnect so that the rear wheels are not being driven. At low speeds, when you're pulling away, or you suddenly sort of swerve, the car detects some kind of manoeuvre. Not sure how it detects that, wheel speeds or G-forces or what, I'm not sure, but if you, I don't know, suddenly go to overtake or something, stick your foot hard down, or you go into the off-road modes, okay, so mud and ruts, grass, gravel, snow or sand, this will start to lock up. It won't necessarily lock fully, but it will start to transfer drive. Okay, so these are actually the other way round to my car. Okay, so that's the prop shaft going in and then out on that side into the rear diff. I should have really put these on the table all the other way round, okay, so that you can kind of see how it relates to my car, but these are the other way round to the way my car is parked. Prop shaft on here, and in there are a load of sort of plates, okay, so they are a mix of these sort of stainless steel and what's called sintered disc plates, which I don't know what they're made of. There's some sort of, I think they're metal in there with a coating. They almost look like kind of glass fibre or something, but I think they're metal with a grippy coating, almost like little tiny sort of round brake pad things. Okay, and there are lots of those plates alternating, and you can see here these ones have got teeth on the inside and no teeth on the outside, and these ones have got teeth on the outside and nothing on the inside. So the way it works is every other plate is linked to the shaft that goes coming in, and then the other ones are linked to this, which drives into the rear diff. And depending on how squished together those plates are, depends on how much drive gets transmitted to the rear wheels. Okay, so you can actually have a sort of half linkage where it's actually slipping, so some of the power is going to the back wheels but not as much as the front wheels. So it could be a 50-50 where it's completely locked and sort of the rear wheels have the same amount of drive as the front, or it could be 60-40, 70-30, or 100 none. It's a very intelligent system. In here there's some electronics, Okay, and the main computer in the car looks at your speed, the G-forces, the wheel speed sensors, the engine load, the off-road mode that you've decided to go in, and it will tell the computer in here to sort of apply more or less pressure to those plates so they slip more or less, or completely disengage, or fully lock, depending on how much drive is needed to the rear wheels. So that's how it works. What is the difference between these two? Okay, so I've got two Gen 4s here, one Gen 3. The main difference between a Gen 3 and a Gen 4 is this thing. Okay, so the Gen 3 has a pump which pumps the fluid. It's an oil, but it's special Haldex fluid, so it pumps that around through a filter. Okay, and there's the control module, and that's it. It basically says pump more or pump less. Okay, so that there is a valve in here. The pump runs at the same, pretty sure that runs at the same speed. So that's basically pumping up pressure, and then in here is a sort of solenoid valve. It's called an N393 or something like that. I forget what it's called, but I'll put it at the bottom of the screen. It's a sort of solenoid valve, but it isn't a valve that just sort of like opens and closes. It's like a pulse width modulated thing, so it kind of buzzes, open and close very, very quickly at high frequency, but maybe it's open longer than it's closed, or it's closed longer than it's open. But by adjusting that sort of in and out thing on the valve, it applies more or less pressure to the piston in here, and that's great, and it works. Okay, but there is a problem. You need a wheel to start to slip and spin before the computer goes, oh, hang on a minute, that wheel's spinning. Oh, hey Haldex, can you lock up a bit more? Okay, Haldex, right, open the valve, get some pressure to those plates. Plates move, they clamp up, and eventually, after probably a couple of seconds, the rear wheels start to engage and drive you. That's not great, really. If you are aquaplaning or losing control on some ice, you don't want to wait a couple of seconds for the Haldex to think about what it's doing. You want instant four-wheel drive. Okay, and that is pretty much what you get with the Gen 4, because it has this accumulator. Okay, so think of this as like a pressure storage vessel. It's got a very, very powerful spring in there. Okay, I mean, never ever try and take that apart. Okay, it's got a sort of piston that pushes up with a high pressure oil from the pump, and then that just holds that pressure ready for immediate action. Okay, so there's none of this kind of building up the pressure. Let's get some steam up and get those rear wheels turning. It's there for instant, millisecond kind of activation. So this one is more sort of proactive than reactive. They claim that, I don't know who they are, might be Land Rover, it might be the people that make this, I'm not sure, but they claim that this can actually sort of kick in before a wheel actually really starts to slip. It's that sensitive. Okay, this one here, you need a bit of wheel spin before it does anything. This one, it's ready for action. Okay, so the response time is much quicker, it's much more reactive. Okay, well, no, I would say proactive, really, rather than this one's reactive. This one something has to happen before it thinks about doing something. This one, it's primed and ready. Okay, so I'm glad that I have a Gen 4 on my car. It is the more superior one. Okay, second hand, these are a lot more money because they're newer and they're the better ones. Unfortunately, you can't swap between them. So if you have a Gen 3, you can't upgrade to a Gen 4. Even if you take the electronics with it, unfortunately, it doesn't work. which is a real shame actually, because there must be loads of people with these who are thinking, wish I had the superior Gen 4. But I have heard of people who have swapped them. Physically they will bolt in, but the firmware inside here will not work talking to a ECU from a vehicle that had a Gen 4 from the factory, okay? Or if you have a Gen 3 vehicle and you put a Gen 4 computer in here, it won't talk. And even if you swap just the electronics, so you've got the Gen 3 electronics but bolted on a Gen 4, it still doesn't work, unfortunately, because this one doesn't have the accumulator. You see, it's just not set up for that. So whatever generation you have, you're stuck with it, okay? And in this video I will dismantle all of these. Okay, so I'll start with the Gen 3 and we'll take this apart and see how we get on. I'm not really sure how this all comes apart. Okay, I'm guessing it's very similar to one of these. But I'm going to take that apart and then we'll take the Gen 4s apart here. I've got these kind of flower pot saucer things here, mainly because there will be oil coming out of these when I take them apart. I don't really want it going all over the block paving. But also there might be some little springs and clippy things and screws, and I'll end up with a pile of parts basically, so I don't really want them pinging off in all directions. So kind of dismantle in there and then put the bits in a box or something, keep them together. That lot really is no use to me. It's just for the purposes of the video really, so you can see what a Gen 3 is like when it's dismantled. These are the ones I'm interested in. My aim is to take these two apart and build one good one out of the two by replacing all of these different bits here. So we've got these kind of sintered plate things in here. I have a genuine Borg Warner pump. Okay, so this is a genuine pump. Alright, there are a lot of cheap Chinese copies out there and they are not very good, alright, so just be really careful where you get yours from. All of these parts that I've bought for the Haldex came from Haldex Repairs Co. UK, alright, in the UK. I did spend quite a lot, okay, most of the bits are not that expensive. I didn't really need a new pump, but I thought while I'm doing all this I might as well fit a new pump really. It would be kind of a shame to refit an old worn out one. And the pump was expensive. I think that was £279 or something like that, maybe even more. And all in all, I think it was nearly £600 for the parts. Okay, so we've got the pump, we've got the plates, we've got a filter, new filter there with the cap. Okay, again, lots of cheap imitation ones out there. Okay, when I sort of take this all apart and that, we'll look at the differences there. There are some good videos out on YouTube by Auto Fault Finder, who Haldex Repairs are sort of part of the auto fault finding outfit. The videos are by Auto Fault Finder, but they show a Haldex stripped down. They show fake pumps compared to genuine ones and fake filters compared to genuine filters. Have a look at those videos. I'll try and point out the things as well in this video, but the guy who's doing the dismantling in those videos, he's actually like Mr. Haldex Repairs, I think. I think his name was Matt in the video, but he seemed to really know what he was talking about, as if he kind of just did that all day long every day. He's seen it all when it comes to counterfeit parts and things like that. So there's a lot of little tiny details to look out for, little things like numbers, stamps, and type of screw heads and things like that. Okay, so just be a little bit careful if you are shopping on Amazon, eBay, what's the other one called, AliExpress. It's quite easy to buy non-genuine parts. You know, they might even be labelled up as genuine when they're not. Okay, so just beware. So I've also got here a seal. Okay, so that's the sort of seal. It's this seal here, okay, which goes between this thing and the body, and a bearing as well. Thought I might as well change the bearing. I do a full service really, and I've even bought a new seal for the control module. I think it's that. I think it's between that and that. It might be between that and that. I'm not actually sure. I'm pretty sure that is the bit that goes in there. You can see that little bit of redness there. Okay, so there's some sort of new, well, it's a metal plate with a kind of red seal around it, but there's a load of O-rings and things as well, and some bolts in there. Okay, so I've got all that, and I'm going to take this apart, take all these apart. We'll start with this one here and see how we get on. The only other thing I'd mention here before I start dismantling, you'll notice that these have a different flange here. Okay, so this one has the later big flange and this has the smaller flange. Okay, these are not the same. They look the same, but they are not the same. That distance there is shorter than that there. Okay, so just bear that in mind as well. If you are stripping down Haldexes, don't end up with a Gen 3 flange on a Gen 4, because it probably won't mate up properly to the prop shaft. Now this one here has the same bit in there. The bit inside is the same as this, and you can actually see the ring of it there, but then it has this big heavy iron kind of cylinder thing kind of shoved on it, and that is done for vibration reduction, noise reduction. It's a sort of harmonic damper basically. You can, using a hydraulic press, remove that bit. Austin said that you can actually get this bit off and leave it looking like that. It's much easier, just throw that in the bin and get hold of one of these. Okay, the other advantage of this one here is you can remove the pump in situ. So if you've got one of these on your car, you can just about, and it is like an interference fit, but the pump will just clear. Okay, Frenchie's Road Trip did a video recently where they tried to service the Haldex in situ on the car, and they could get to the filter just about. I forget sort of the orientation of this, but the filter I think was up above the prop shaft, but they managed to reach up and deal with that. And then they tried to remove the pump, and they couldn't. At first they thought it's not going to clear, and then with a bit of wiggling they just got it out, but absolutely no chance of doing that on a car with the big flange.
Don't say flange again.
Okay, so if yours has got one of these, it might be worth, if you want to service your Haldex, you're going to have to take it off the car. Okay, you're going to have to separate this from the prop shaft. Now, to do that, you need to look in Haynes manual. Okay, what you have to do basically is remove the bolts and then stick 2 bolts in from the other side with another sort of dummy bolt in. I don't know the sizes, it's all in the Haynes manual, and tighten down, and that kind of pushes the prop shaft apart, but you have to undo the prop shaft sort of mid mountings and things like that, and possibly drop the exhaust. It's a right pain, and I'm going to have to do that soon. Once this is all built up and ready, the next thing is that I put it on the car. Okay, so I'm going to have to take my old Haldex off, so I'll be doing that separation. Okay, if you've got one of these, it's the same method, but you'll have to take it off the car in order to then remove this big nut, okay, which is a 24mm nut, and you need to use an impact gun to sort of kind of spin that, loosen it, and then you're going to have to bash that way to pop it off the splines, and then you can get your pump out. A right pain in the arse really, absolute ball ache of a job if you've got that big flange. Alright, so just if you're about to tackle this job and you're watching this video thinking, oh, I'm going to do my Haldex, I'm going to service it, I'm going to try and do it on the car, if you've got one of these, it's not going to work. Okay, this type, yes, you probably get lucky and you can just about wiggle that past. You can do it in situ on the car, okay, which Frenchie's road trip I'm pretty sure did in the end. So right, that's it, enough talking, and I'm going to put the camcorder on the tripod, and then I'm going to start dismantling this. I think what I'm going to do is clear the decks a little bit, okay, and then put this sort of in the middle of the table and then start pulling it apart. Okay, what I'm going to do now is dismantle this Gen 3 Haldex, and then I'm going to move on to the two Gen 4s. All three of these have a big 24mm nut here. It really needs an impact gun with a socket to sort of remove that using a bit of sort of inertia to spin it. Otherwise, if you just use a socket set, you're just going to end up spinning this, you see. Even if you kind of put it in a vise on the bench, that is still going to spin. Okay, so an impact gun is the way to loosen that. I've already done that, and what I'm going to do now is I'm just going to remove this nut and just see if this pulls off by hand. If it doesn't, then I'm going to have to just give that a bash down there by sort of lifting this, and just to sort of push that shaft out. Okay, now I don't want to damage the end of that shaft, so I might have to put the nut back on a couple of threads, but let's just see how I get on here. So there's the nut, and oh, hang on, it's moving. Oh, there we go. It's come off. That's good. I was expecting to have to hammer that. So this coupling, I don't know what that's called really.
Flange.
A sort of flange kind of thing here is quite rusty. All right, it's very old. That bit has been exposed to the elements for many, many years. It's really rusty, and there's a bit of rust inside just where this has been disconnected from the prop shaft and then just left out in the scrapyard or wherever it came from. Okay, so a bit of rust there. I'm not going to be reusing this piece. Okay, that's not the same as the Gen 4 one. Okay, this distance here is longer, so that will probably go in the bin. One thing I'd mention here, this is, I thought was a rubber seal, but it's not. That's metal. The seal is here underneath that. Okay, so that's just a metal sort of dust shield, okay, which doesn't seem to be removable. Okay, inside are the splines. These ones actually are in quite good condition, but it's just a shame the thing's so rusty, and I don't actually need a Gen 3 for my car. I'm only dismantling this for the video. So, next thing, let's remove the wiring and the ECU off here. Okay, so let's have a little look here and just see. Probably need to get some pliers to remove these plugs. Right, let's try and... It's almost tricky to know what you do with the little tabs on these. Do I press? Do I pull it? Oh, I'm not sure. Let's have a look here. I think that's a press. Yeah, press it down. No. Well, if you pull it too much, it breaks off. Okay, so yeah, that hole there goes over a little sort of barb. So I will let's try and get this thing off first, and then put that back in, because these connectors can be worth keeping. The question is it the same as the Gen 4? I'm not sure really. When I take that apart, we'll have a look, but it's an 8-pin connector with 5 of the pins in use. Okay, so 3 of them haven't got metal contacts inside. Right, there's that. Let's just see how this works now. Okay. I'm not sure if that's really meant to come off there, but it doesn't seem to want to stay on there now. Okay, yeah, I think I've probably broken that off inside. Let's just see if I can get this one. Come on. Okay, that one's come out as well. I have no idea if that's actually meant to come out of there, you know. I don't think it is. I think it's meant to be just rocked back slightly so that this hole goes over the little barb thing. So you don't pull it right out, you just rock it back a bit. So I've probably broken both of those. When I get to the Gen 4s, I'll try and be a bit more gentle with it. Okay, so that connector is a 2-pin, and that is the pump connector. So let's remove the control box. Then I'm going to remove the pump. Get all the electrical bits out of the way. So what have we got here? 2 Allen head bolts. There, look like M4, 4mm, but let's have a little look and see. Right, I think that's a 4mm Allen head. Let's just try this. Oh dear, that is tight. Right, let's use a socket. There we go. Okay, right, so I was expecting some kind of circuit board, but I think that must be under here. Here we've just got a capacitor and the connections for the solenoid valve, which I think is this, and that I'm guessing is a sort of pressure sensor. Okay, this whole thing comes loose. Some sort of feedback pressure sensor or temperature sensor. Oh, here we go. Right, this comes off. Okay, so that's interesting because I've bought another one of those. Be interesting to see if that is the same across them. Okay. Right, just put that on there. So, there's definitely signs that water has got in here. Okay, not right into here, but attacking the seal there. This is the valve, the N373 valve. Some sort of metal washery thing there. Is this going to come out? Oh, look at that. There we go. Now, what is that? That is a sensor. I'm guessing it's a pressure sensor. No hole in the end. It looks like that bit just gets pushed up, and there's probably some sort of I don't know, something inside that gets squished and changes its resistance. Not sure. But this is the solenoid, the N373, and that doesn't really want to come out. But I'm just going to persuade it. There we go. Right, there we go. There it is. Now, what I'm looking for is a sort of date stamp. There doesn't seem to be one on there. Be interesting to see if this is the same as the Gen 4 one. But this is basically a solenoid valve. There's a coil inside there, 2 connections, and when you apply probably 12 volts, the inner bit, not this bit here, not the outer, but the bit inside moves up and down, so it sort of move and back. By pulsing this at high frequency, you can control the oil flow. There's a sort of pulse width modulation. Okay, so you can send more oil to the plates or less, depending on, I'm guessing, I think there's oil in and oil out. So when you're not applying it to the plates, they sort of bleed back and release. Okay, so by pulsing that, you can control effectively how much drive is going to the rear wheels of the car. When I've done all this, and replaced my rear diff and my Haldex, I want to look at a project to actually take control of this and manually control the locking, so that I can effectively have a sort of a diff lock switch on the dash where I can flick a switch and it kind of locks up, and I know that I've got 100% drive going to the rear wheel, so sort of 50-50 fully locked kind of front rear. Okay, right, I'm going to take the pump off now. So the Gen 3 has this smooth end, okay, Gen 4 has a knobbly bit there. That's the easiest way really to identify if you've got Gen 3 or Gen 4 when you're lying underneath the car, because you might not be able to see the accumulator. But if you look at the pump, you see the knobbly end, then that tells you which type you've got. Okay. Now I did see something on the auto fault finder videos about the genuine pumps and filters having bolts with sort of little lines on, almost like grippy lines on the bolt heads. That doesn't have one. This filter on the Gen 4 here does have it, and it's on the Gen 4 pump, so it could be this is not a genuine pump. I mean, it is black in colour rather than sort of aluminium coloured, but I think the Gen 3 pumps are black. That's another way of telling the difference. Yeah, that is interesting, because I'm also on the filter housing, I'm not noticing any kind of numbered stamps which you get on the genuine ones. So this Gen 3 could have been fitted with a cheap replica pump and filter bought from various online marketplaces. Right, let's try and get this bolt out here. It's a bit tricky getting in there. Right, that one's got a load of white powder on it. Loads of it. All in the hole there. I don't know if that's oxide or it's a thread lock that somebody put on that has just crystallised. That hole hasn't got any, that hole's got loads, so. Okay, so, is this going to come free? Oh, dearie. Come on. It shouldn't be this difficult, I don't think. Okay, well, I could just give it a little bop with a hammer. Let's just give this a little tap. It's all going in the bin anyway. Come on. Okay, what I'm going to do is I'll leave that for now. Come back to that once it's more stripped down. So I want to get this out. I'll get the filter out. Let's just do the filter now and just see what's in there. Now, are they the same size as the pump ones? Yes, they are. I don't know what thread that is. It looks like M5 to me. I don't think it's M4. I think that's M5 thread with a 4mm Allen head. Right, how do we get this off? Right, don't tell me this one's jammed as well. There we go. Just needs a little bit of tapping to get that off. Right. What a mess in here. There's... I don't know what the heck this is. Some sort of white powder in here. It's got no... Oh, there is actually a number stamped down there. Apparently the cheap copies don't have a sort of tooling stamp on them. If you see numbers and details, then it's more than likely a genuine one. Right, that's the top of that. Now this one here, apparently if you just try and pull that, it just breaks off. But what you shouldn't do here is start kind of gouging it with a screwdriver. The best way to get this off is to use a pick thing like this. Carefully run it around the outside to remove any corrosion and stuff, but without damaging too much on the inside, because otherwise the new cap won't seal. I mean, this one's scrap anyway. The idea is, I think, that you're meant to be able to pull that and then just pull it out, but that's not going to work. Let's just try it with the pliers. Yeah, no, that just breaks off. Rubbish. Okay, so this is why people recommend the pick, because you have to kind of hook it out. Don't sort of try and hammer something down the side. Right, okay, let's... Flipping heck. Wow, this one is so corroded that it's really stuck in there. Just see if I can... There we go, come on. Do this carefully. There we go. Right, so that should come out a lot easier. Okay, so this is the thing with seal. So that's why you shouldn't hammer anything down the side there. There's a lot of crud in here. A lot of mess. Okay. So that, I don't think is that. That's just literally a plastic cap. The filter element is down here. Now, another thing that was mentioned by Auto Fault Finder. If the filter has a spring, it's probably a cheap copy, not the genuine item. The genuine filter does not have a spring. Okay, let's see if we can use a pick. There we go. It's, oh God, I'm going to get a face full of old oil. Oh, come on. Come on, right. Yuck. Well, this is why I use the flower pot saucers, because that is half full with old Haldex fluid. There is the filter, and that's quite different to the Gen 4. The Gen 4 filter's a lot bigger. Right, okay, I'm going to try and soak this up somehow. I'll just leave that in there to soak that up. Right, so what I want to do now is to drift out this main shaft so that the sort of body comes away from the clutch basket thing here. So to do that, I'm just going to pop the nut back on. Oh, come on. I've got Haldex fluid all over my hands now, all over my gloves. It's so slippery. Right, let's see if this works. I'm just going to kind of hold this. There we go. Wow. That's a lot of roller bearings there. Goodness me. 3 concentric rings of roller bearings. Right, okay. What have we got here? This is, okay, so let's just have a look at this. We've got a ring for roller bearing. I'll put those there because we're running out of room here. Another ring. Another ring. And then that, which is some sort of metal spacer plate thing. And another one. These are nice bits of stainless steel, I think. Wow. Okay. Those look like magnets to me. Is that a magnet? No. It's a little roller, little bearing there. There's quite a few, there's loads of them. Another ring. Right. Lots of those kind of square rollery things, plus some other rollers which sat in these slots here. How this comes apart, I'm not sure. I think there's like a circlip there, which I'll need to expand out. Okay, so we'll come to that in a minute. Let's look back at the actual body here. Somewhere here is the sort of the main piston, which I think is this. Okay. So when I watched the Auto Fault Finder video, he was dismantling a Gen 4, and he just kind of hit this, and it just shook off the piston thing. Oh, there we go, another ring to come off. Right, let's try and get this seal out. This is going in the bin, so let's just see if we can. Come on. Can't get the sort of outer ring of the seal out. There we go. Right, that's the remains of the seal. Then we can see there's a ball race there with a circlip. So I'm going to get my circlip pliers, try and remove that, and then somehow I think the bearing has to come upwards because the circlip's holding that in place, and then the remains of this should bop downwards, but we'll find out. Finally. Okay. So this bearing should come out now, but I'll need to drift it out from that side. It's a 19mm socket put on the wrong way round, and that actually sits nicely in there. Let's just give that a bash. There's the bearing. Right, so I'm hoping now that the bearing's out, the rest of this will kind of come out. Right, another piece of metal. It still looks like more comes apart though. Oh, look, it does. There we go. Right, there is another piece of metal, but that I think is the piston because that's got a rubber seal on it. Okay, so that's the bit that actually moves in and out, and there's oil holes behind there. Okay, so this I don't think comes out. I don't think it does. This ring here is a different coloured metal, so I think that comes out. Let's just see if that will come out. Right, that is coming out. There you go, that's another piston with a seal on it. And then this bit here, I think will also move. Yeah, it will. It's held in tightly. Right, another ring with a seal. So there are 3 of them. Concentric rings, all with seals on. Loads of metal rings, and that is it. That, I'm confident, is all the same piece of metal. Okay, so that has sort of like 3 concentric piston rings that move out. All of these have got oil holes. Okay, so that is it, dismantled as far as I can, apart from the pump. Pull this out now. Yeah, that oil's now gone. Right, okay, now what's happening now is the cover of the pump is coming off and it's left the actual motor behind. Now this has got yellow and black wires, which I think are the genuine colours. Maybe this is a genuine pump, but this pump is well and truly seized in there. Right, I'm going to have to give this a real good whack with a hammer. There we go. Well, so I thought, it's actually now broken the motor apart. It's left the remains of the actual pump compressor as such in there. Okay, so this is all scrap basically, and if your Haldex is this hard to take apart, it's probably worth binning it and getting another one that's better condition. This pump is completely seized in here. Right, well, we can see there the armature inside the motor. This black bit's just a plastic cover. Not sure if this is genuine or not. The wire colours are correct for the genuine, but I don't know. I've got a feeling it's a cheap one. I just don't think this is going to come apart now. Let's see if so that's as far as I can go with this. All of this is going in the bin. I haven't actually stripped this completely. I wanted to get the clutch plates out of here. I can't see how this comes apart. I think, looking at this, there's a big circlip. Great big circlip around there. Let's just see if I can get that out. Aha. more bits of metal and some plates, the thick ones at the end. This one looks like it's the end one, and then there's a steel one. Where here we go, look at this. The sintered plates are all here. Oh, we've got the inner drive cog thing, splined drive. It's not really a cog, is it? I suppose it's a sort of output thing. And then in here we have, yes, it's going to be tricky with that this clip. Oh, come on. There we go. Right, one circlip, and then all of these come out, and there we go. There's a bearing there. Okay, so that is one piece of metal, albeit sort of welded kind of shafts, and that's the basket, as they call it. And we have then a big chunky metal, sort of probably stainless steel kind of plates at the end. And let's count these out. Now there was one thin one already, so stainless, sintered, there's one pair, 2, 3, 4, 5, get off there, 5, 6, 7, okay, so 7 of each, 7 thin stainless and 7 sintered. These ones actually don't look too bad, you know, they've still got the kind of grippy coating on them. I mean, it's entirely possible that this came from a Freelander 2 that was never driven off-road, and it was sort of light driving at low speed, and therefore the Haldex never actually did much. Maybe the Haldex had a fault and never really locked up these plates. These look in excellent condition. So 7 of each, and then big chunky one on each end. Now that one there's beveled and this one isn't, okay, so they are different. Okay, so this sort of square profile one goes at the back, beveled one goes on the outside. Right, there we go. That is it. Apart from the pump remains that are well and truly stuck in the housing, that's a complete dismantle of a Gen 3 Haldex. Okay, loads and loads of bits here. I was surprised at the amount of parts that came out of this, really. I think the Gen 4 is simpler, it doesn't have as many parts in it. Right, that's it. Most of this will get thrown away. Might keep this. Trouble is, I just don't know if that's in working order or not. Don't want to go and sell it if it's faulty. Okay, right, so next I'm going to clear all that out of the way and strip down one of these Gen 4 Haldexes. Okay, so here we are the next day. It's a lovely sunny Sunday afternoon, and in a moment I'm going to be taking apart these 2 Gen 4 Haldexes. Before I do that, I'm just going to show you one last thing. I realised that the last remaining thing that I hadn't done was to try and get the remains of this motor out. Okay, so this is the actual compressor bit of the motor, which was well and truly jammed in the housing. Okay, so I had to give it a big hammering with a big club hammer and crowbarring it. This housing is scrap. Okay, I mean, it was going to go in the bin before. It definitely is now, because chunks of it have come out and that face there is all gouged up. Okay, but I just wanted to get this out, and after about 2 hours of hammering and swearing, it came out. Okay, it's in a terrible mess, and you can see there's a lot of oxide there. It was basically aluminium rusted into this hole here, but I wanted to get that out just to see what was on the other end of it, really. So there is a little gauze thing there and some screws, and yeah, I think this must be a cheap replica pump. I'm not sure. The wire colour code, yellow and black, is correct, but I just don't really think a genuine one would have jammed in like that, really. It really had to be forced out of there with a lot of hammering, okay, and a lot of kind of levering. So it came out eventually. The actual sort of inside here are not in too bad condition, actually, really. There's not that much debris stuck in that little filter gauze there, but yeah, I mean, it's just a shame that happens, really, because when you're servicing your Haldex, you want to change the filter, which goes in here. That's quite easy to remove, but then on the end of the motor there's another filter, you see, and you need to be able to take this off. Even if you're not actually changing the motor itself, you shouldn't really need to change the whole motor, but you do need to kind of clean up this end of it. Certainly on the Gen 4s, the gauze on the end of the motor and the filter are the two things, apart from new fluid, of course, that you would actually need to do regularly. So if taking the motor out destroys the housing, well, that's just not going to work, is it? So this is all going to go in the bin, most of this anyway. Some of these things, like this is quite nice, you see, that's in reasonable condition, a little bit of surface rust on it, but I don't know, I might sell some of these bits on eBay just as used spares. These plates here, even though they're used, they look like they've never actually seen any action. I mean, they look like the brand new ones that I bought. So maybe this came from a Freelander 2 that had never been off-road and maybe had some sort of fault that meant the Haldex was never actually doing anything. I'm not sure, but everything looks in very good condition here, really. These stainless rings there, they don't look very worn, they're all nice and shiny and new. This is rusty. Somebody might want it, you never know. So I'll have a rummage through that, but the rest of it is just scrap and it's going to get thrown. So I'm going to get that lot out the way. I'm then going to do the Gen 4s here. I've realised that I've filmed over 2 hours of footage just doing this and looking at the diff. So I'm probably going to put this dismantling into the next part. Okay, so this lot was part 3, and I'll make part 4 for the Gen 4. There we go, easy to remember. Okay, so part 4 will be the Gen 4 dismantling. I'll try to drop them sort of at the same time, or very sort of short time between them, really, so that it kind of flows from one video straight into the next. But nobody wants to sit and watch a 3-hour video on me swearing at Haldex. Okay, so I'll be doing a lot of editing, trimming that 2 hours down, try and get it under an hour, but if I put the Gen 4 in as well, it's just going to be too long. Okay, so that'll be in the next video. This video is the Gen 3, which is going to end now. In the Gen 4 video, you'll be glad to hear I've dug out my whiteboard. I'm going to be doing one of my famous whiteboard lectures, and we're looking at how the Gen 4 works and what's different between that and the Gen 3. Right, that's it for this video, and I'll see you in Gen 4 dismantling part 4. Don't forget to like and subscribe. Thank you very much for watching, and I'll see you in the next video. Bye.